Niels Bohr's model of the atom? I mean, this thing wasn't just a good idea. It was a Nobel Prize-winning revolution that totally redrew our map of the universe. But what happens when a brilliant idea, one that seems to explain literally everything, starts to unravel? Well, that's the story we're getting into today. The beautiful, brilliant flaws of Bohr's atom.
And, this question, it gets right to the very heart of how science works, right? It's not about finding these unbreakable, set-in-stone truths. It's really just a relentless search for better and better explanations. Bohr's model was an absolute masterpiece, for sure, but the universe is a tricky puzzle, and it turns out even the most brilliant minds can't see all the pieces at once.
All right, so put on your detective hats because we are about to dive into one of the most fascinating cases in the history of science. We're going to examine the evidence, follow the clues, and figure out why a theory that seems so perfect was, well, destined to be replaced. And look, this isn't about tearing it down. It's actually a celebration of how science, at its best, is this incredible, self-correcting engine of discovery. Every great detective story needs a case file, and this is ours. Each one of these points you see is a clue, a piece of evidence that made scientists stop and say, hold on a second, something isn't quite right here. This list is going to be our guide as we unravel the mystery. So let's start with the first and maybe the most obvious problem.
Okay, so right from the get-go, there was a problem. A big one. For a theory that promised to unlock the secrets of the atom, it had a surprisingly short list of things it could actually, explain.
So here's the bombshell. Bohr's model was basically a one-hit wonder. It worked flawlessly for hydrogen, the simplest atom there is, with just one electron. But the moment you tried to add a second electron, the whole thing just fell apart. Imagine a brilliant architect who designs the most perfect one-story house you've ever seen, but has absolutely no idea how to build a skyscraper. That was Bohr's model. It was a beautiful foundation, but it just wasn't enough to build the rest of the universe on.
Okay, so the model was a hydrogen specialist, fair enough, but you'd think it had mastered its one and only subject, right? Well, not quite. As our scientific tools got sharper and more precise, we started seeing things that Bohr's model simply couldn't account for. These little ghosts in the machine that hinted at a much deeper, much weirder reality.
Imagine you're looking at what seems to be a single, solid, thick line. But then you zoom in, way in, and you realize it's actually a whole bundle of tiny individual threads. That is exactly what happened when we looked at the light coming from a hydrogen atom. Bohr's model said we should see one clean line, but what we actually saw was this fine structure of multiple closely packed lines. It was such a tiny detail, but it had huge implications. It was a crack in the foundation of the theory, and it just kept getting wider.
And the plot thickens. When scientists took these atoms and put them in a magnetic or an electric field, those fine lines didn't just sit there. Nope, they split apart, kind of like a frayed rope. This was a super clear signal that the simple, elegant picture of electrons orbiting a nucleus like little planets around the sun, it was just too simple. The universe, it turns out, was a whole lot messier, and frankly, a lot more interesting than that.
So, we've seen the evidence you could literally observe, the cracks in the theory you could see with your own eyes. But now we get to the final, fatal blows, the conceptual problems that proved Bohr's model wasn't just incomplete, it was fundamentally, well, wrong.
And this, right here, is the heart of the matter. The problem wasn't just a few missing puzzle pieces, it was the entire puzzle board. Bohr's model was like a beautiful castle built on sand, and the tide of a whole new scientific revolution, quantum mechanics, was about to wash it all away.
And here they are, the two fatal flaws. First, Bohr's model pictured the electron as a tiny, solid little ball zipping around. But the new science of quantum mechanics was revealing a shocking truth. Electrons are also waves, kind of spread out in a cloud of probability. It was a totally mind-bending idea that Bohr's model just couldn't handle. And second, the model broke a fundamental law of the universe, the Heisenberg uncertainty principle. Bohr's model claimed to know an electron's exact location and its speed at the same time. But Heisenberg proved that's impossible. It's like trying to nail Jell-O to a wall. The more you know about where it is, the less you know about where it's going. This wasn't just a small error. It was a head-on collision with a fundamental truth of reality.
So, where does that leave Bohr's beautiful broken model? Was it all for nothing? Not a chance. Not even close. In science, even the most glorious failures can be incredible successes. Bohr's model was the bridge that carried us from the old world of classical physics to the strange new landscape of the quantum realm.
And you gotta love it, we can leave it to Bohr himself to have the last word. He knew that the path to discovery is just paved with mistakes. His model wasn't a dead end, it was a signpost. Every single time it failed, it was pointing a giant glowing arrow at a deeper, more profound truth about how our universe works. Its brilliant flaws were the breadcrumbs that led us to the next great leap in human understanding.
And that's really the beautiful, humbling lesson here. Today's unshakable truths are so often tomorrow's charmingly flawed stepping stones. It really makes you wonder, right? What revolutionary ideas are hiding in the cracks of our own understanding today, just waiting for the right person to ask the right question?